Hi everyone, and welcome to the Level Up Your Game webinar series presented by StormIT. As an AWS Advanced Tier partner, at StormIT we spend a lot of time learning and getting our hands dirty with AWS services so we can help companies like you to make the most out of AWS Cloud. And in this series, we are focusing on how iGaming companies can leverage the AWS Cloud for their business. We also have the previous session, and there we actually covered how iGaming companies can accelerate the game with AWS Edge services in order to lower the latency, why it's actually critical for iGaming companies, and what benefits the AWS Edge services can offer. If you missed that one, make sure you watch it because you will find a lot of useful information for iGaming workloads, and it's also a great intro to the series overall. But during today's session, we will discuss scaling topic and how to scale your game with the power of AWS Cloud. And I'm here together with Adam, our AWS guru and AWS Pro Certified Solution Architect.
Hi guys.
But we are super happy to welcome also our special guest, Radu Dobrinescu, Senior Partner Solution Architect at AWS. Hi, Radu.
Hi Nazar, hi Adam. Hello everyone, and thank you for joining this webinar. I'm really thrilled to be here. I currently work as a partner solutions architect at AWS. So that means that I get to work with awesome partners such as StormIT on cool solutions that help our customers really leverage the benefits of AWS.
Thank you, Radu. We are all super glad to have you here. And mm, we have some logos of iGaming companies. We also mentioned last time that a lot of iGaming companies kind of are not sure if they can actually use AWS Cloud as an industry. And the short answer is yes, sure, absolutely. And a lot of leading companies within the industry do so already with AWS. And if you kind of really would like to discuss a little bit more, you can reach out to me or to Radu. We also touched on that in the previous webinars. You can have a look, or you can go a little bit deeper on that one. But here's the agenda for today. And as I mentioned, it will be all about scaling, horizontal, vertical scaling. What is the difference and use case? How you can scale the application tier, database tier scaling, and what nuances we have to take into consideration. Then also we will touch on what are the options and benefits of auto scaling in AWS. And in the end, kind of we will always would like to sum up everything and show the real world example from the industry. And we will use one amazing public case study for this. So we have a lot of cover. So let's start with the scaling, and I'll hand over to Adam. Adam, please, the stage is yours.
Thanks Nazar for the introduction. And first we need to compare horizontal versus vertical scaling of resources. Through vertical scaling, you can increase or decrease the capacity of existing services instances by upgrading the memory, which is RAM, storage, processing power like CPU or even GPU. Usually this is done manually in AWS. To scale horizontally, you add more resources like virtual machines to your system to spread out the workload across them. Horizontal scaling is especially important for companies that need highly available services. But every time you consider horizontal scaling, make sure first that your application supports such a deployment, because we have seen in the past that everybody wants to start using horizontal scaling, but not every application is capable of it. While AWS autoscaling primarily focuses on horizontal scaling for its elasticity and cost effectiveness benefits, vertical scaling might still be necessary in specific scenarios where increasing the resources is more appropriate. Right? For example, if your memory is not enough for your application, you will need to scale vertically. So, what are some great autoscaling benefits? Definitely, the adapting to demand. Autoscaling allows resources to dynamically adjust based on real-time demand, ensuring optimal game performance during peak hours. Then we have a cost efficiency because you don't have to run an infinite number of instances, and just this scalability eliminates the need for this over provisioning of the resources, thus reducing operational costs. Then we have enhanced user experience because this all ensures uninterrupted gameplay, reducing latency and downtime even during high traffic periods. And you also get highly available service because usage of auto-scaled resources brings the possibility to quickly switch between unhealthy and healthy resources. And you will definitely stay competitive because you will get seamless game performance and enhance customer satisfaction and loyalty. Every dynamic game needs computing power to run. This is where we begin our autoscaling journey in AWS. We start by understanding how autoscaling helps. Here we have two graphs. One represents not using dynamic scaling, where we have a fixed amount of capacity. When we implement any form of scaling, we aim to adjust our capacity to meet the demand. This is definitely not an easy task, but AWS has us covered and help us to cover this task. And let's see how and which services we can use. iGaming companies usually start with Amazon EC2, which is basically a virtual machine somewhere behind. And AWS autoscaling because virtual machines are overall more understandable, and the next step is start using AWS autoscaling for services that support it. Or they can start with today's so favorite solution, Elastic Kubernetes, or native AWS service Elastic Container service for containerized applications. Containerized applications tend to be easier to autoscale because they are usually already prepared for multiple deployments. And we also should talk about AWS Lambda or serverless in general, which is already from the start autoscaled resource because of its serverless nature. So let's dive a little bit deeper into these services and look how they can help you quickly start in AWS and run your game. So as the first AWS service, we have Amazon EC2 as autoscaling that is used around virtual machine in AWS. It's a powerful tool that allows gaming companies to dynamically adjust their resources based on demand. So you can get several virtual machines based on the definite conditions. What it also brings is a quick healing process because you can switch between those EC2 instances by load balancing. When one of the instances get unhealthy, it will be automatically decommissioned and replaced by a healthy virtual machine. What needs to be definitely mentioned here again is that this is only possible if the application or your image is stateless. Not every application can be split over multiple VMs or deployed to multiple virtual machines. So we have two services in AWS that we can use to deploy containers. It's Elastic Kubernetes Service and Elastic Container Service. We will start with EKS, which is AWS Managed Kubernetes Control Plane, and it allows you to autoscale your infrastructure with EC2 or Fargate instances to automatically adjust the number of Kubernetes nodes based on the current demand or load. This ensures that your applications running on Kubernetes clusters have the necessary resources to handle varying levels of traffic without manual intervention. And Radu, can you tell us what is the difference between autoscaler and carpenter?
Yeah, sure, absolutely, Adam. So we do have two different approaches. Basically, it's the same function, as you said, to scale the EC2 nodes where the workloads are running. But the cluster autoscaler, so it is a time-tested, mature solution for doing this autoscaling. Um, it actually relies on the auto-scaling groups to manage the nodes with scaling based on predefined node group configuration, right? So you predefine the type of instance and the size of instance, and then the auto-scaling group in the backend will just increase or decrease the number of instances in a group to support the workload. Carpenter, on the other hand, is a more modern auto-scaling solution, and actually it will have an intelligent allocation component in the sense that it will dynamically select the right size and the right type of instance based on the precise workload requirements, right? And it will also automatically optimize the cost and the system availability. In other words, Carpenter will always select the most cost-efficient instance that can support the container workloads. And Carpenter also includes a bin packing algorithm basically that means that it will continuously seek the most cost-effective instance. So if your workload decreases, then Carpenter every 10 seconds will scan the workload and will actually will find a more cost-effective solution and the more cost-effective instance type or size to accommodate that workload. And by the way, Carpenter is also open source, so it can be used even on other Kubernetes clusters. It's not restricted to EKS on AWS. I hope that answers your question, Adam.
Yeah, definitely. It's helpful to see the difference between Outpost Scaler and Carpenter. We will now switch to other service from AWS, which is Elastic Container Service. Uh, it's really similar to EKS from like an outside view. It has some great auto-scaling features that allows you to also auto-scale your containerized application based on predefined scaling policies. Maybe Radu, can you tell us something about the scaling policies?
Yeah, absolutely. So again, with ECS, ECS relies on the construct of a service to offer auto-scaling capabilities to containerized workloads. And basically, you can have three different options for defining how the auto-scaling should happen, right? One of them is the target tracking, and this is basically automatically adjusting the number of tasks or containers to maintain a specific metric value. For example, CPU usage, right? So conceptually, you can think of this working as a thermostat. You just set the value for the CPU usage like you set the value for the temperature in your home. And then the auto scaling will go up and down just to keep that target value of the CPU usage in this case. So that is one option. The other one is step scaling, which actually allows you for a more granular control. So you scale in predefined increments, and this is based or triggered by CloudWatch alarm. So again, you can say if CPU usage goes above a certain level, let's increase the number of tasks with a certain increment. And the third option is schedule scaling. So for those workloads that are more predictable, so let's say you have an application and you know that it's being used during the day, not so used at nighttime and in the weekends, you can actually schedule how your scaling policy should work, right? So it's let's call it a proactive scaling operation. So these are the three options that you can use depending on your use case.
Yeah, great to hear. And also, it seems, and I have heard it many times from our customers, that EKS and ECS are very similar services. So, Radu, can you tell us what the differences are between them?
Yeah, absolutely. And this is indeed a very common question that comes up. Many customers will ask, okay, if I'm moving my workload to containers, what is the container orchestrator that I should run and what I should use on AWS, right? And again, it's a matter of choice. Both services have the same function to run containerized workloads in a secure, scalable, highly available way. The difference is that ECS, so Elastic Container Service, this is a native AWS service. You know, is an orchestrator that will run on AWS. And the way it works is basically you create an ECS cluster and you describe there your task definitions, your task, your services, and everything is integrated with the EC2 service where the containers are actually running with services like the load balancer service so that you make sure that you can support these high available architectures, natively integrated with other services like CloudWatch for monitoring, VPC for networking, and so on. I would say even the entry point in terms of skill set, it's much easier with ECS, right? So you don't need that much knowledge to adopt ECS. On the other hand, EKS is our managed Kubernetes offering, right? So if you come from Kubernetes background, if you already have some knowledge, then maybe EKS is a much better suited option. But again, if you have already standardized your application on Kubernetes, then it will be much easier with EKS. The control plane is completely managed by AWS, and basically, for a customer of EKS, is just a matter of orchestrating the data plane or the worker nodes, right? And we talked about Carpenter or cluster autoscaler, how to define that. But the complexity with EKS comes also from the big ecosystem of tools that you can use, right? Although there are again native integrations with the services like Elastic Load Balancing, with CloudWatch, with the managed Prometheus and managed Grafana for monitoring, you still have to manage a lot of the, let's say, connect workloads. You can think about, I don't know, how do you do DNS inside of the AKS cluster? How do you do this monitoring? Any other type of solutions that with ECS, they might be already built in, completely managed by AWS. So that gives like a much easier entry point into ECS.
Mhm. Great. Thanks for the insights. I think again it's really helpful, and we will get to serverless now. AWS Lambda is a compute power that is really serverless. It dynamically adjusts the number of function instances based on the incoming events or triggers. So it's not running 24/7. It only depends when it's called by another service or something in your application. This means that as your iGaming platform or game itself experiences increased traffic, Lambda automatically scales to handle the load, so it can be basically spitted automatically into multiple many functions there. It's usually combined with API gateways to provide computing power for your APIs, and I will show a real-world example of the usage at the end of this webinar. Manual managing database capacity can take up valuable time too, and can lead to inefficient use of database resources, so it can cost you a lot. Mainly in unpredictable and growing business like iGaming, it makes sense to use autoscaling also for your databases. Let's, let's first split it by SQL versus no SQL because AWS offers autoscaling for both of these database types. We have Aurora autoscaling feature of Aurora and Aurora serverless, which are for SQL, and we have DynamoDB for no SQL. Usually, the way how companies work is in a hybrid environment because all older applications tend to need an SQL solution, and it's time consuming to migrate them to no SQL solutions. But usually, they want to leverage DynamoDB at least in some ways because it really brings a lot of benefits and it's very good together with serverless services like AWS Lambda. So now we start with the databases, and first we have Aurora Autoscaling, or more often Aurora MySQL and PostgreSQL database. It's for the iGaming companies with dynamic workload handling, optimizing cost by adjusting database capacity based on demand. This ensures consistent performance during peak gaming periods, improving player experience with fast response time and reduced latency. This makes the Aurora a valuable service for delivering a high performance, cost effective, and reliable gaming experience.
That's true, Adam. And if I may just step in here, just to share some of the feedback that we have from our customers, depending on that, right? So this is a great feature from Aurora, the fact that it can scale based on the demand for read and write operations, and that ensures that the database can handle the high demands of I/O during peak times. However, we got feedback from customers that it was very difficult for them to keep control of costs, right? Because you cannot really control the reads and the writes to your database. It depends a lot on how the application is written. It depends a lot on the traffic to that application. And basically, this actually resulted in let's say, a very low predictability of their cost. And with AWS, as you know, our roadmap is influenced by customer feedback, and we listen to this feedback, and we actually launched an IO optimized configuration that basically eliminates the separate IOPS charges. So now instead, all the IO costs are included in the overall instance and storage pricing, right? And this can actually uh, usually it results in a significant decrease in the cost for running any IO intensive application. In some cases, it can be up to a 40% reduction in cost Aurora configuration. That's a good tip for keeping control of costs with this auto and leveraging the auto scaling capabilities, of course.
hmm hmm Great, thanks, Adu, again for helpful insight. I think there will be some customers interested in that. I have seen this in the past, so definitely thank you for that. And let's went to another service, which will be Aurora Serverless. In some cases, it makes sense to also use Aurora servers because it's a great option for unpredictable workloads or the infrequent access patterns. What is also great, it automatically pauses during period of inactivity to save codes, which is really different than normal Aurora. You are not able to stop it. Ideal for unpredictable workloads, and it also scales database capacity up or down based on the application needs. And for NoSQL databases, we have DynamoDB. Its seamless scalability accommodates growth without manual intervention, ensuring the reliability and availability essential for uninterrupted gaming services. This makes DynamoDB autoscaling a valuable choice for delivering a cost-effective, high-performance gaming experience tailored to your player demands.
All right, so we talked about how AWS services operate and how they function, what are the benefits, but now let's see their application in a real world example and how a company was actually able to significantly increase their scalability and availability of services by leveraging AWS. It's about a company called WhatWap. By now, they're a globally operating company with a team that is focused on creating mobile games and to bring people together through gameplay experiences. In 2022, WhatWap decided to migrate their backend game operations to AWS, and we can see on the slide a simplified diagram of their architecture. Um, for cost-effective storage, WhatWap uses Amazon S3, and this is an object storage service that offers scalability, data availability, security, and performance built in. And they are also ensuring that the players have a smooth experience by leveraging our CDN solution, CloudFront. And this will help reduce the latency for global players. The core services actually that they use is basically the Elastic Kubernetes service on top of which they run the open source platform Nakama. And this actually allowed them to support up to 40,000 simultaneous players on EKS and EKS's capabilities for scaling nodes and scaling infrastructure depending on workload requirements. They now can support up to 900,000 monthly users and 300,000 daily users. So that is a big workload that they can leverage with EKS and Nakama on top. And also they leverage some cloud native services like CloudWatch for monitoring and open party solutions like Prometheus and Grafana. So that also allowed them to gain some increased visibility into game performance and also of their code performance, right? So that allows them to much faster identify and alleviate any bottlenecks in their application. So overall, by migrating to AWS, they laid the groundwork for innovation and for expansion in the future. And now, WhatWap is focused on improving the social and competitive features of their games to make their games more exciting to play. And this is really easy for them having all their operations up on the updated infrastructure. And that really makes it simpler for the WhatWap engineers to develop and to share the new features that they release in their game. And that's the story for WhatUp. Happy to provide more details on that if anyone is curious. Adam, back to you.
Thanks, Radu, for telling us about this approach. But we also see right now that we can have a different approach in AWS for many games, mainly the newly deployed games. We have a couple of services here. What we have is Amazon Cognito for user authentication that ensures security of user private data and identity. It's serverless natively. Uh, we have many APIs here, and as APIs need to be scalable, we have two solutions from AWS. We have AppSync API and API Gateway. These serve different use cases, but let's note that let's not delve too deeply into them. For scalability, we also have S3 here, which is similar to what Radu described. Uh, it's serverless natively. We have another layer here is AWS Lambda, which provides computing power and is auto-scalable. And also, I just want to mention that data for this game can be saved in DynamoDB, which, as I described, it's serverless, but you can get also some auto scaling features that can help you here. And we also leverage a simple email service that can help you send emails. It also is a serverless thing. What's great about this approach is that the starting costs are really low and they only increase as the application scales. You can use this same infrastructure or architecture for a couple of users or millions. Every layer of serverless will grow with the demand for the application. And I cannot forget to mention the management and deployment of the entire serverless environment can be managed using infrastructure as a code tools such as CDK, Serverless Framework, and Terraform. But it's very similar to what Radu also described. It can be also deployed by CDK, Terraform.
Great. So that's it for today. So today we showed why scaling is so critical for iGaming to ensure great player experience. So we spoke about AWS services like EKS, ECS, auto scaling, RDS Aurora and Aurora Serverless, Lambda, and other serverless services that enable developers to build and deploy scalable and reliable games in AWS Cloud. If you have any question regarding AWS and iGaming workloads, please feel free to reach out to me, Adam or Radu. And in any case, we are looking forward to see you next time. Have a great day. Bye.
Bye.
Bye bye, everyone.